Have you ever wondered why the ocean tastes salty, while the water from your tap doesn't? This intriguing question is the starting point of our journey into the fascinating world of water. Yes, water, that seemingly simple liquid, comes in more than one type: fresh and salt. Fresh water, as the name suggests, is water that's devoid of significant amounts of salt. It's the stuff that fills our rivers, lakes, and even falls from the sky as rain. It's what we drink, bathe in, and use to sustain life on this planet. On the other hand, salt water, which makes up about 97% of Earth's water, is primarily found in our oceans. Its saltiness, or salinity, is due to the presence of dissolved salts, mainly sodium chloride, also known as table salt. With these basic definitions under our belt, we're ready to dive deeper. Now that we've defined fresh water and salt water, we can explore what happens when they meet. Fresh water, the stuff we drink and bathe in, has some interesting properties. It's more than just a thirst quencher or a medium for cleanliness. It's a life-sustaining force with unique characteristics. One of these is its density. Fresh water is less dense than salt water, which means it tends to float when the two meet. It's also why ice, which is solidified fresh water, floats in your drink. Another fascinating property is its freezing point. Fresh water freezes at 0 degrees Celsius, a fact that plays a crucial role in our planet's climate and the survival of many species. Then there's the life-supporting aspect. Fresh water is home to countless organisms and forms the cradle of life on Earth. But remember, fresh water is a precious commodity. Despite covering about 70% of Earth, it makes up only 2.5% of the total water supply. Fresh water is vital for life on Earth, but it's not the only type of water we have. Salt water, on the other hand, covers 71% of our planet's surface. Its characteristics are quite distinct. The first thing to note is that it's denser than fresh water, thanks to the dissolved salts. This density difference is why you might float more easily in the sea than in a pool. Salt water's freezing point is another intriguing property. It's lower than that of fresh water, which means it can stay liquid at chillier temperatures. So if you've ever wondered why oceans don't freeze over in winter, well, now you know. And let's not forget about the life it supports. From microscopic plankton to giant whales, the ocean's salt water is teeming with a diverse array of life that's distinct from freshwater ecosystems. On average, there's about 35 grams of salt in every liter of ocean water. That's like dissolving a handful of salt in a liter of water. While fresh and salt water may seem different, they often come together in fascinating ways. When fresh water and salt water meet, the result is far from a simple mix. It's a remarkable natural phenomenon that creates a whole new type of environment, rich in life and biodiversity. This is where we step into the fascinating world of estuaries, the areas where rivers meet the sea. Now picture this: a river carrying fresh water from land, colliding and merging with the salty sea. This is not a sudden clash, but rather a slow and steady dance. The fresh water, which is less dense, floats on top of the denser salt water, creating a gradient of salt concentration. This gradient, or halocline, is a fluctuating boundary that ebbs and flows with the tides, the seasons, and the amount of river inflow. In these estuaries, the mingling waters birth a unique type of water called brackish water. This is neither fully fresh nor fully salt, but somewhere in between. The specific salinity can vary greatly, from nearly fresh to nearly saline, depending on the balance between the river's outflow and the ocean's tide. And here's where it gets even more interesting. The differing densities of fresh and salt water create layers in the water column, each with its own set of conditions and characteristics. These layers affect the types of plants and animals that can thrive in these areas. For instance, many fish species lay their eggs in the less salty, upper layers of an estuary, while their adult forms live in the saltier, deeper parts. These estuaries, the magical meeting places of fresh and salt water, become unique, vital ecosystems. They act as nurseries for a variety of marine life, support a wealth of plant species, and serve as crucial feeding grounds for many kinds of birds. So, picture the estuary not as a battleground where fresh clashes with salt, but as a complex, dynamic dance floor where two different worlds meet, mix, and give life to a third, equally important world. So, the meeting of freshwater and saltwater creates unique, vital ecosystems. Freshwater and saltwater. Two forms of the same element, yet so distinct. We've explored their individual properties, the unique role each plays in supporting life on our planet, and the intriguing interplay that occurs when they meet. Fresh water, the lifeblood of our land-based ecosystems, quenching the thirst of every creature and plant and nurturing our agriculture. Saltwater, the vast, mysterious oceans, home to a myriad of marine life, and playing a crucial part in regulating Earth's climate. When these two waters meet in estuaries or haloclines, a captivating dance ensues. A delicate balance of physics and chemistry, creating a dynamic, life-giving interface. This fascinating interaction, a testament to the intricate workings of our natural world, is a reminder of the interconnectedness of life. So, next time when you sip a glass of water or taste the salt in the sea, remember, it's not just water, but a whole world of science and life.